of 2 times 2 times 2 times 3. So when you break a number down to its prime factorization, you should only have prime numbers, or numbers that can't be broken down any further, as your final factors. So let's take a look at a first couple here. I'm going to do the first couple, and then hopefully you guys can finish the rest of this table. So the left side of the column, you can use a calculator if you need to. That's fine. So the first one is 7/10. Now, 7/10 written as a decimal is the following: 0.7. Okay, that is obviously terminating. Now, the prime factorization of 10. 10 breaks down into 2 times 5. Neither one of those numbers break down, so that would be the prime factorization of 10. Take a look at 6/21. Now, if I used a calculator, I would see that it breaks down to 0.2857714. And in actuality, this continues to repeat. This does actually repeat. If you had a calculator screen big enough, you would see that it would keep repeating. So this is a repeating decimal. Okay, now I want to break down the prime factorization of the denominator. So let me just get rid of this real quick. So the prime factorization of 21. 21 is nice and easy. Breaks down to 7 times 3. Okay, so go ahead and do the rest of this table. Hit pause, and when you're ready, I'll reveal the answers here. So go ahead and fill in the rest of this, and then we'll talk about any patterns that you possibly can see. Okay, so at this time, go ahead and hit pause. Okay, so go ahead and compare your table to my table at this point. Give you a second to just check those out. You'll see that I wrote in blue the ones that repeat, and I wrote in red the ones that are terminating. So let's take a look now at the questions that are written below. It says, look at the terminating decimal rows. Do you notice anything interesting about the prime factorization? So go ahead and take a look at those rows. You can see all the red. So notice terminating. Oops, that's a 5, not a 3. Sorry. Terminating. That has 2s and 5s. That's terminating as 2s and 5. This just says 2s. That just says 2s. That has a 5. This has 2s and 5s. So what I notice is that the terminating decimal rows only include 2s or 5s in a prime factorization of the denominator. Okay, you can see that if you look again up here at the red. I can even circle these guys. 2s and 5s. There's a 5. There's 2s, 2s, 2s and 5s, 2 and 5. Okay, all of my red terminating decimals. Now, what do we notice about the repeating decimal rows? Well, let's take a look at the blue. Well, now, all of a sudden, there's no 2 or 5. Well, it has a 7 and 3, I should say. This has a 7. This has a couple 3s. This one has a 3, a 2, and a 5, but it's repeating. It has a 2 and a 5, but it also has this 3, so it's repeating. So one of the things that I notice, that if it includes a number other than a 2 or a 5, it's going to be a repeating decimal. So go ahead and write that down. If the prime factorization has numbers other than 2s or 5s in the denominator, in the prime factorization, then it will be repeating. So again, take a look up here at the blue. You notice all the blue have numbers other than 2 or 5. So again, there's a 7 and a 3. There's a 7, some 3s, and a 3 down here. So what can we conclude? Well, down here, if you want to write this down, if a denominator has prime factors of only 2s or 5s, it is terminating. It can have 2s and 5s. It could have just 2s. It could have just 5s. It could have combinations of 2s and 5s. But it must include only 2s or 5s. Therefore, we would know that that fraction is terminating. Okay? So that's one way to identify if a fraction is terminating or repeating without using a calculator. So go ahead and take a look at the next page. So now on this page, we're just going to take a look at a couple patterns, and hopefully it won't take very long to catch on and see what's happening here. So the first thing, I'm just going to do the first one by hand, and then I'll leave you guys to do the rest. Again, you can use a calculator. So 1 divided by 9, to write that as a decimal, or 1/9 as a decimal, is 1 divided by 9. And I notice that is 0.1111 repeating, or 0.1 repeating. 2/9 as a decimal is 0.222 repeating, or 0.2 as a decimal. 3/9 is 0.333 repeating, or 0.3 repeating. So go ahead and fill in the rest of those. I'll give you a quick pause. Go ahead and fill in 4 through 7 on the 9s. Okay, so you can see the rest of my table, and you can see 5/9 is 0.555 repeating, 6/9 is 0.6 repeating, 7/9 is 0.7 repeating. So one of the patterns that you should notice is that when the denominator is 9, the numerator is going to be repeating. So here you can see that 2/9, since my denominator is 9, the 2 is going to repeat. If I have 5/9, the 5 is going to repeat as my decimal. Now take a look at the 11s. The 11s is another one that has a nice little pattern that will help us be able to memorize some decimals. So again, you can use a calculator if you want, but I'll quickly go through this one. So 1/11 is 0.0909 repeating, so 0.09 repeating. Sorry, that handwriting is bad. Let me try again. So 2/11 is 0.1818 ... or 0.18 repeating. 3/11 is 0.2727 ... or 0.27 repeating. So go ahead and fill in the rest of those. Maybe you can see what the pattern is. I don't know, but go ahead and see if you can fill in the rest of those and hit pause. Okay, so if you take a look at my orange column here, you can see that 4/11 is 0.36 repeating, 5/11 is 0.45 repeating, and so on. So maybe you were able to discover the pattern, but one of the things I want you to notice is how do these numbers relate to 9? Well, if you notice, all the numerators times 9 is your repeating decimal. For example, 1 times 9 is 9, 2 times 9 is 18, 0.18 repeating, 3 times 9 is 27 repeating, 4 times 9 is 36 repeating, and so on. 7 times 9 is 63 repeating. So one of the things that we can conclude here, and go ahead and you can write this down underneath, the pattern, when the denominator is 11, the repeating decimal is the numerator times 9. So it's a multiple of 9 will be the repeating value. Okay? So a couple neat little patterns here. When you have 9 on the bottom, the numerator just repeats. When you have 11 on the bottom, just multiply the numerator by 9 to get your repeating decimal. Okay? So take a look down here at these problems. Now these aren't on your page, so go ahead and write these down as I do them. For example, 8/9. Try your best not to use the calculator. I'm going to do the first few so you can kind of see what's going on and what the pattern is. So 8/9. If we were to continue that table, I'd be able to say that 8/9 is 0.8, 0.8 ... or 0.8 repeating. Now, what about if I have 15/99? Well, if you were to take your calculator and do 15 divided by 0.99, divided by 99, you would notice you get 15 repeating, or 0.15 repeating. Well, what if we extend the denominator even further out? What if we have 999 or 999 as a denominator? How's that going to affect our decimal? Well, the pattern will continue. The 148, or whatever's in the numerator, is going to repeat. So 0.148, 148, ... and that just becomes 148 repeating. Oops, forgot my decimal there. Okay, so you can see the next two, same thing, 163/999. Notice that there are 3 9s on the bottom. There are 3 numbers that are going to repeat in the decimal. That's important, as you'll see in a couple minutes. 163. Or 163 repeating. Keep forgetting my decimal there. Same thing with 227. I've got 3 9s on the bottom. Therefore, 3 numbers are going to repeat. ... or 0.227 repeating. The reason why I keep saying that is because now look at the bottom one. Now I have 50/99. Now remember I said since I have 3 9s on the bottom, I need to have 3 numbers that repeat, but I only have 2 numbers in the numerator. No big deal. How can we add a number? Well, we can hold a place value. And here's what you do. You simply write this as 0.050. Notice I now have 3 numbers that are going to repeat. So that's now going to be 050 ... or 0.050 repeating. Okay, so go ahead and try these last three over here on your own. 8/11ths, you can kind of see how the table would follow. 8/11ths would be the next one in the table, so you can figure that one out. 8/9, use the table, and then 13/99, see if you can catch on to what we were talking about earlier to do that one. So go ahead and hit pause, and I'll reveal the answers in a moment. Okay, so go ahead and check your answers. 8/11ths, again, take the numerator, multiply it by 9. 8 times 9 is 72, so 0.72 repeats. Here we have 9 in the denominator, so I'm going to have one number that repeats, and that's going to be the numerator. So one number repeats, 0.8 repeating. Now here's one of those tricky ones where we have 3 numbers in the denominator, 2 numbers in the numerator. Just add a 0 to get those 3 numbers to repeat, so 0.013 repeating. Okay, take a look at the next page. So go ahead and copy down and fill in as many of these as you can. Again, I'll reveal the answers in a couple minutes. It should not take you that long if you get the pattern from the previous page. There are a couple tricky ones. We'll talk about that in a second. But go ahead and try to fill in the rest of this. Okay, so go ahead and check your answers with what I have here. I'll give you a second here to run through those. I'll scroll down in about 10 seconds here. Or you can actually hit pause so you check all your answers. And then hit play when you're ready to go again. So hopefully you got most of these right. I circled in red some of the ones that I thought were a little bit more tricky. For example, letter F and G, that's 0.05. That should be 0.04 because you have 2 numbers in the denominator, so you need 2 numbers that repeat, so you need the 0 placeholder. K, L, and M, I'm sorry, J, K, L, and M, same thing. M particularly, there's 4 numbers in the denominator, so I need 4 numbers that repeat. So I need a placeholder there in front of the 2, so I have 4 numbers that repeat. So if I were to continue this decimal, it actually goes 0298, 0298, ... forever. Okay? Alright, so go ahead and scroll to the bottom. Okay, so down here I've got 6 problems for you guys to do. What I'd like you to do, actually I'm going to do the first 3 for you, but now we're going to go in reverse. We're going to go from the decimal, the repeating decimal, to the actual fraction. So what I like to do is I like to identify what's repeating. So what I'm going to do, for example, number 1, I'm going to put a line over everything that repeats. So 0.107 repeats. Now, how many numbers is that repeating? That's 3. So I know I'm going to have 999 on the bottom because 3 numbers repeat. Then put whatever repeats in the numerator. So that's 0.107 repeating. Take a look at number 2. Here I have 0.75 repeating. So how many numbers repeat? That's 2. So I know my fraction is going to be over 99 because that's 2 numbers repeating. And my numerator will just be whatever repeats, which is 75. And finally, number 3, how many numbers are repeating? There are 3 numbers repeating, so therefore I need 999 in my denominator. And then please put whatever number repeats, 087. Now we wouldn't normally write a decimal like that, so we would write, we wouldn't normally write a fraction like that, so we'd write 87 over 99. So go ahead and do 4, 5, and 6 on your own. Go ahead and hit pause. Okay, go ahead and check your answers, 4, 5, and 6. So 17 repeats, 2 numbers over 99. 6 repeats, but 2 numbers actually repeat, 060606. But that's going to be 6 over 99. Here I have 3 numbers repeating, 009, 009, so I need 3 9s on the bottom. What repeats? 009, but that's really just 9. Okay. Okay, the last section here, or not the last section, second to last page here is a quick little quiz to see if you're on top of things. So go ahead and answer 1 through 6 quickly. Try to write them as fractions. Don't be fooled because some of these are not repeating decimals. Go ahead and try that real quick and then check your answers. So go ahead and hit pause. Okay, so go ahead and check your answers.